Hello students, in this lecture we will discuss rank nullity theorem, and before discussing rank nullity theorem we will look what is null space. A null space is actually what? The solution of linear homogeneous system of equation whose coefficients are a matrix A. So we find a null space of given matrix A. Let A is Aij m cross n. Let A be a matrix of order m cross n. Now we are to find its null space. Null space is the set of all n-dimensional column vector x such that Ax is equals to 0. Means all those n-dimensional vector which satisfy the system of equation. This is a linear homogeneous system of equation, and all those vector of n dimension which satisfy this system of equation are the solution of null space. And number of independent solution are called the basis of this null space, and number of these basis number of independent solution in basis of this null space is called the dimension of null space. And this dimension is actually called as nullity of matrix A. So to calculate nullity of matrix A, first we are to calculate how many elements exist in the basis of null space of A. How many elements which exist in basis of A is dimension of null space, and which is equals to nullity of A. So null space is the solution set of system of linear homogeneous equation with A as the coefficient matrix, and the dimension of null space, that is number of element in basis or number of independent solution of null space, is called nullity. Now the rank nullity theorem states that A be a m cross n matrix with rank R. We have already discussed rank R and nullity L, a matrix A with order m cross n and with rank R and nullity L. In that case, rank nullity theorem states R plus n should equals to n, where n is number of column in given matrix. N is what? Number of column in A. Now we have a problem. Now we are to find the basis of null space of matrix. Basis is what? Basis contains independent solution of null space, and null space is what? Solution of all possible solution which satisfy Ax is equals to 0. So before calculating its solution, we will convert given matrix A into echelon form. It is an easy way to calculate its basis. So here we have A is a 3 cross 4 matrix. So to convert it into echelon form, we use two elementary transformation. First we use R3 replace with R3 plus R1, and R2 replace with R2 minus 3R1. Hence the first element of second row and first element of third row become 0. Now taking as 0, we will try to convert this element into 0. So for that we will use the elementary transformation. R3 should replace with R3 plus R2, hence third row becomes 0, and there are only two non-zero rows in echelon form, hence the rank of given matrix will be 2. Now we are to find the basis of null space. Using rank nullity theorem, we can calculate nullity, that is number of independent solution of null space. Here number of columns are 4 and rank is 2, so nullity should be 4 minus 2 is equals to 2. It means number of independent solution of null space must be 2. Null space, basis of null space is independent solution of this system of linear homogeneous equation, and this system of homogeneous equation is equals to, this is A given coefficient given matrix, and this is just equals to a coefficient matrix is this echelon form matrix. So In place of A, we will use a resultant echelon form matrix. So we get equations from here: x1 minus 2x2 plus 4x4 is equals to 0, and 7x2 plus x3 minus 12x4 is equals to 0. From second equation, we obtain the value of x2, which is equals to 1 by 7 minus x3 plus 12x4. Putting this value of x2 in this previous equation, we can get the value of x1, which is x1 is equals to minus 2 by 7 x3 minus 4 by 7 x4. So the solution of this linear homogeneous system will be of the type x1, x2, x3, x4, where x1 is minus 2 by 7 x3 minus 4 by 7 x4, x2 is minus 1 by 7 x3 plus 12 by 7 x4, and x3 and x4 are independent. So there are two independent solutions. First we will take x3 as 1 and x4 as 0, and second time we will assume x3 as 0 whereas x4 is 1. So when we take x3 1 and x4 0, we will get, suppose x1, capital X1 is minus 2 by 7 minus 1 by 7, 1 and 0. And when x4 is 1 and x3 is 0, we get another solution vector which is represented by x2 is minus 4 by 7, 12 by 7, 0 and 1. Or these vector can be written as minus 2, minus 1, 7, 0 and minus 4, 12, 0, 7. So in this way we will calculate basis of null space.